Hello, everyone, and welcome to another SynMax webinar. I'm Sophia LaChapelle, an account manager here at SynMax, and I'm joined by Ryan Nickerson, one of our Hyperion data scientists, and Tony Frangi, our head of energy fundamentals. Today, we'll be introducing you to a new feature that's been in the works for quite a while. That's called Production Studio. Production Studio is a what-if tool, allowing you to run your own simulations and scenarios using either SynMax's own assumptions or yours. Ryan is going to give us a little bit of an overview, and then we're going to walk through some market relevant use cases while using the tool. As always, we'll have a Q&A session at the end, so please submit your questions and we'll get to them as we go. And with that, I'll hand it off to Ryan to get us started.
Cool. Yeah. Good morning, everybody. I'll try to do this at a speed that's not too fast, not too slow to not bore people with the details, but still give you a good idea of what Production Studio is. And to do that, we'll be going over what it is. So this will be, what it is, how to use it, special use cases that it can handle, how to integrate it with our data and specifically our short-term forecast. And then the use case that we'll be talking about towards the end will be a potential buildup in Haynesville, Louisiana production and how Production Studio makes that easy to simulate, customize. You can do all sorts of different scenarios to your liking. So what is Production Studio? Like Sophia said, at the high level, it is a what-if tool, but specifically, it's a what-if tool that bridges the gap between lagged state production data, SynMax's proprietary satellite tracking data sets, and our short-term forecast. So what that means is, some states are delayed by, over a year in some cases. So this allows you to kind of fill in the gaps with what has happened historically or what you think will happen in the future. And it uses SynMax's internal data set. So that's the satellite tracking for rigs and frac crews, the well completions, the TIL times for wells. And then it also continues off of, if you want, SynMax's short-term forecast. If you disagree with our short-term forecast, you can also input your own time series of data to simulate what would happen if, say, SynMax says 10 wells come online, but you think it's 12, or if SynMax says there's six active frac crews and you think it's going to be 5, and so on and so forth. And you can run Production Studio in single simulations with exact values, or you can run it in a sort of a Monte Carlo simulation where you give it a range of values and you can run it, hundreds, thousands of times in just a few seconds. And that's what we'll do at the end of the presentation. And then a benefit of Production Studio is it gives you the source data. It allows you to visualize your results. If you're using the front end or Excel, it'll visualize them for you. And then Python is just an easy way to really dig into the data straight out of the API and then also the calculated results out of Production Studio. So what can Production Studio do? Right now, there are 4 simulation types that you can run, and we're going to look at 3 of them in this webinar. The first is a forward single simulation, and what that is you can input your own well completions and frac crew time series, and also put in your own well type production profile curves to simulate production out into the future. Branching off of that is the forward multiple. So this is the ranges that I was talking about. So you can give it a minimum and a maximum of well completions and frac crews each month and run that, as many times as you want. And Production Studio will, pick a value in between your ranges and plot the results for you. On the flip side, there's the inverse, which is, or you have a clue of what the future production is going to be, but you don't know the number of well completions or the number of active frac crews that will produce that. And then a flat is similar to inverse, where you want to simulate a flat production into the future, but you don't know how many well completions or frac crews it'll take to maintain that flat production. So in this, we're going to do a forward single, an inverse, a flat, and then we'll do the multi-range Monte Carlo at the end. Okay, so why use it? Basically, it makes forecasting a whole lot easier, a whole lot faster, and it takes away the time for you or your coworkers to write machine learning models, to do, all the models that we already have trained, write all the calculations that Production Studio does, and et cetera. So the big power behind Production Studio is that it's using SynMax's data sets, the rigs and frac crews tracking through satellite imagery, are cleaned, state scraped permits and production reports, and then the short-term forecast to fill in that time delay. It also, in my opinion, and I hope you agree, it's very easy to understand. It's easy to use. The results that it outputs are easy to view and visualize, and understand what Production Studio gave you. For those new to SynMax and you maybe haven't heard of the short-term forecast or haven't had a chance to look at it, basically what the short-term forecast is it's our internal well-level production forecast for the lower 48 in Canada. And what this is it takes the state reported production and reports, permits, and for wells that the state reports production for, we continue that forward in a decline curve for 10 years. For wells that are permitted but maybe not completed, SynMax will also model the completion dates and the TIL times when they're going to come online. And for every single well, that goes forward 10 years. For states that are delayed by a year, right, it'll fill in that year delay and then continue those forward for 10 years. So this is really our kind of internal well level production model. We also have the long-term forecast, which is aggregated up to the subregion level. But Production Studio uses the well level data as its basis for its starting point, and then also the calculations that it does in terms of gathering assumptions on well productivity, frac crews, well completions, and et cetera, that we'll talk about when we go through an example. Okay, so this is kind of branching off of the why use Production Studio. Basically, if you wanted to solve a question like what production is going to look like in Haynesville, Louisiana in the next 6 months, or say you don't have access to our short-term forecast, you would have to go through a ton of steps to recreate what Production Studio does. And those steps include using our API or maybe a third-party source of your data, writing queries, scraping data. You would have to then model your own well completion times, your TIL delays, your IP rates, your well declines, all that fun stuff that takes months and months to get your models right where you want them. And then you would have to plot, visualize, clean your data, and et cetera. So these are all things that Production Studio can do for you. All right, Tony.
Yeah, and going into what types of market scenarios we would simulate, we picked Haynesville, Louisiana, as that's the most important basin in terms of its effect on the Henry Hub, and at least trying to come up with some realistic scenarios for this year. Last year would have been obviously a very different market environment, but for this year, when looking at producer guidance, it suggests that we're going to have new rigs and frac crews in Haynesville, Louisiana, and the forward natural gas price environment supports that guidance, with current prices are well above the break-even $2.50 per MMBTU for cost of new wells. And also, we're having fewer mergers and acquisitions year over year, which then encourages potential production expansions, and it reduces the amount of consolidation when you have fewer mergers and acquisitions or fewer M&A. And then finally, most importantly, what's driving the price is the LNG demand growth coming out of Haynesville, and it's going to support the production growth. So as long as the LNG demand growth is there and the LNG market is there, and the spreads between the US and Europe are at levels that are well above break even for variable cost of transportation, we should see production growth, or the market will incentivize production growth out of Haynesville.
Thank you, Tony. Okay, so yeah, how do you do that in Production Studio? How do you simulate a growth in production in a specific subregion? So I wanted to try to hit as many of the tools in the simulations as possible. So we're going to do this in three steps. First step using the Excel add-in, the second step using the SynMax front end, and then the final step using the Python client. So those are currently the three ways to access Production Studio. In the first simulation, we're going to do the flat production, which is, our baseline. We expect production in Haynesville, Louisiana to increase. So let's figure out our baseline flat production, how many frac crews to maintain flat as our minimum. Our second that we're going to run is simulating a large build in production using the inverse simulation. And we'll use that to get our maximum of active frac crews needed. And then in the third step, we'll use those min and max to run a Monte Carlo in the Python client using the forward multiple simulation to get 10 scenarios, maybe some more likely than others, and we'll kind of walk through each and pick out our favorite. Okay, so bear with me with the videos. Zoom doesn't like it too much, but the first step is the Excel plugin, and this is going to be, if you're familiar with our current energy Excel plugin, it's going to live inside of that. And if you haven't already, you can hit the update button, and it'll get you Production Studio. You'll see it there. And what's nice about the energy plugin is it's all directly in Excel. So I know a lot of our clients work out of Excel. So the data is all there. You can run your simulations in there. It'll give you the data from the calculations it makes, the data from the API, and it's all like centralized and ready for you to integrate it into your existing workflows. So let me pull up this video. And sorry if I go too slow or too fast, but basically what I'm doing here is I'm starting a new tab and I'm going into our energy plugin and clicking Simulation Builder. So this Simulation Builder is Production Studio. And the first screen that you see might look familiar if you've used the Formula Builder. So what this is you're setting up your data queries. You're setting, here I'm setting our subregion, and you can also pick the date, county, operator. And once you hit go, it queries all the data. At the top here are the 4 simulation types. So we're going to go over to flat, and each simulation type has its own interface with the values you put in. So this simulation start date is the first simulated date. So we're doing April 1st is our first simulated date. I'm telling Production Studio that I want to hold gas flat. These are the other fields that you can put in here. So I'm just hovering over them quickly, but we're going to leave all of these default. The default is calculated in the back end using historical data. And then here, I'm going to set the simulation duration to 9 months just for the rest of the year. And these two bottom rows are the decline or the production profiles for gas and oil. But again, we're just going to use the default. So once the simulation is complete, it populates into a new sheet. And at the top, you can see all of the fields and inputs that we put into our simulation. You can see kind of the studio inputs is the query, and then below that are all of the simulation inputs. The first section here that I'm highlighting is the production profile curves that we left default. So I'm just showing them so you can see what they are. But basically oil's flat in Haynesville, and you can see that we have about 18,000 as our IP rate per well. Next to that is the vintage charts by month. And then here are the important pieces. So this here are the calculated monthly completions, and these are the calculated active frac crews needed to hold a flat production. So basically out of this, we have 9 frac crews, and that is what we are going to use as our minimum. So let me to next. Okay. So in this simulation, we have our minimum. Now we're going to try to get our maximum. And this is using the front end. So this is on our website. If you've used Data Center or Geo, it lives right there in its own kind of tab. And on the front end, the benefits of using it is it has a very easy to use UI. It's very, every step has a tooltip to let you know what you need to fill in, what data type it is, the order you should fill things in. And then your results are centrally visualized right there for you. So this is a great tool if you have one simulation you want to run. You want to run it quick and you don't want to write a script or open up Excel and deal with all of those screens and data. You just want to see the results. So here is that. So like I said, it's on our energy page and it has its own tab on the left. And step by step, what you do here is you fill in your, similar to Excel, the region and operator and all of that fun stuff that you want to run your simulation on. So we're just going to quickly go to Haynesville. And then as you hit update, you can see the key metrics panel on the right is highlighting a bunch of, the latest known oil production, the latest known gas production, total number of wells, a quick breakdown of the top operators. And from here, we're going to select our inverse. We're going to pick the same starting date of April. And from here, you have two factors to fill in, is what we call them. So the first is the future production profile. So again, you need to pick oil or gas. We're starting with gas. And I am now removing a couple extra months to have it be the same length. And for this, I wanted to simulate kind of a ridiculous build just to get our high side, but basically I'm just doing a flat 0.2 BCF per day increase every month for 9 months in Haynesville, Louisiana, just to simulate our high end. Other fields in this are similar to what was available on the Excel. So if we were to do a flat, we could skip all of this and just put in the simulation duration. If we did a forward, we can put in fields like the frac crew, well to frac crew ratio, which is the number of wells each frac crew completes. We could do the well efficiency profile, which would be changing, year over year, how more efficient do wells get as a scalar. Here I made a little mistake, put a little too big of a build at the end. But that's what's nice about these graphs in the factors is you could see what you're putting in visualized before you hit submit. Here is that well improvement and the well type curve. Again, I'm just going to leave it default. So we're using apples to apples across our platforms. But now that all of that's entered, we can run the simulation and view the results. So for an inverse forecast, what you see as the main result are the number of wells needed to achieve the future production that I put in each month, and then the number of frac crews. So we're more interested in frac crews. And you can see kind of going through here, it's 13, maybe 14 at this last one on the high end. And here is just the result of it showing exactly what I told it to do. This is a 0.2 build each month. And now we're going to take these results and we're going to plug it into the Python. Okay, so the Python is my favorite tool to use. I mean, I'm a Python developer, so I'm a little biased, but the nice thing about the Python is it's built right into our existing Hyperion client. So if you've used the API to get data through Python, it's built right into that. And it's a new class function that you use exactly the same as before. So you initialize your connection, you pick which data sets you want, you set your filters. And then instead of passing it through to a specific API endpoint, you pass it into Production Studio. And Production Studio will handle everything from there. The nice thing about Python is you build your own payload, so it's not hidden behind a UI. You can customize everything inside of it. There's a ton of extra fields. And then it's also the most powerful way to run simulations. In our example, we're running a multiple forward Monte Carlo. I've run this with 1,000 and it completes in less than a minute. Whereas if you try to run more than 10 on, say, the front end, it might crash. And if you run more than, say, 25 in Excel, your Excel will freeze up. So Python is definitely the most powerful tool if you want to run a bunch of simulations all in one go. So this is an example notebook that I wrote for this. So let's give it a second to load up. so it's not super blurry. But basically what this is running through the, there we go. Running through, maybe this looks familiar to you, but you connect to the client by putting in your own access token and building your payload. And where this differs now, instead of passing that payload into an API endpoint, you pass that payload into Production Studio. These payloads still look exactly the same if you've used this before. So in our payload, we're setting our start date in this example is for the base data. So this is not the simulation start date, but the data start, and then our subregion for Haynesville. And we are initializing our simulation object. And as that runs, it'll give you this simulation defaults object. And what this is basically all of the pre-calculated fields that the front end had, that Excel had as kind of suggested values. You have these to your exposure if you're kind of unsure about what you want to do. And then this is the payload for Production Studio. So this is all of from the front end, these are the factors that you put in. So this would be the well completions, the frac crews, the type curves for gas and oil, your simulation start date, everything that had a UI in Excel or the front end, this is where you would input here. So this is everything that Production Studio needs to know. In our example, we're doing 9 as our minimum, 14 as our maximum for frac crews. We're going to use default curves and start in April again. And here is some example code. So this is not part of Production Studio, but some example code of how you can plot all of your simulations. And you can see each and every one. So we ran it 10 times. All of them are different, I promise. And as you kind of scroll through these, you can kind of, say which you think is most realistic, which is your favorite. So I slowed down there. I think 6 looks pretty good. 8's not bad, but we're going to stick with 6. So to extract your preferred results, you can go into the results object and print out number 6. And since it's random, it's Monte Carlo, you want to look at the studio inputs part of it to see what the calculated values were. So again, we said 9 as the minimum, 14 is our maximum. And you can see here in that numfrex list that it stayed within those bounds. Here are the values that were used in number 6. And from here, say you think in month 4, 14 is high, you can bump that down to 13 or 12 and run it again. So that's kind of the power behind running a simulation many, many times, is you can see a bunch of options, figure out what's close, and then tweak it from there. Going forward, if you wanted to extract the data out of it, the data is also stored inside that results object. So in this example, I'm pulling out the user forecast. So what the user forecast is the month by month vintage data. So what that means is wells are grouped together based off of their first production month. So you can pull out the data similar to how these graphs are made here. So that would be your way to make these graphs. Inside of that results object are also the profiles for the wells, both oil and gas. It'll give you the time series for well completions or frac crews, both historically and simulated, and all of the data calculations, suggested default values. It'll give you all of that inside of that result object. Yeah, so this is kind of what's to come. This is our roadmap for version 1.5 that we're going to try to release this quarter. And what's included in that for the front end will be all of the features that maybe you're used to in data center or geo, where you can create new tabs, you can share and save and download your results, send a simulation to a coworker and say, hey, check this out. All of that functionality we're hoping to move over to Production Studio. In the Excel plugin, we want to add running simulations inside the cells themselves. So if the UI is too slow, or you just want to change one thing and you don't want to pull open the UI to change just one single value, we want to add that object at the top where it had all of your parameters and query filters. You can fill in kind of like a template there and then hit a button and hit run, and it'll just grab all of that information. You can skip past the UI. And then we're also just want to add improved UI features just to speed things up. The UI in Excel is definitely a little slow and clunky. So we're hoping to change some UI features there. In the Python client, we want to write some pre-canned plotting functions just to make it easy. And we also want to be able to allow you to download to Excel. So, you can run your simulations in Python. And then if you like one, you can save it to Excel so that it would look like the same sheet you would get out of the plugin. And then in terms of universal across all three, we want to add new production type curves. So hyperbolic, exponential, maybe a combination halfway through, exponential for the first 5 years and then hyperbolic the rest, or vice versa. We want you to be able to select the level of aggregation. So what I mean by that is right now you can only input a time, like one time series for well completions, or one production profile to be used for every single well in your simulation. And this select level of aggregation is meant to be, say I do Haynesville, Louisiana, but I want to put in a different well profile for different operators or different counties. This select level of aggregation will allow you to do that. And then we also want to add geological features as a way to filter and query data, basin, sub-basin formation, and all that good stuff. And that's all I got. Back to you, Sophia.
Awesome. Yeah. So everyone can go ahead and submit some questions in the chat. I do have two here. Are the type curve parameters default? Are they computed on the historicals?
The default suggested values that you get are calculated using historicals. So in Python, that start date I had in my beginning query payload is basically setting the range for that historical. So in my example, I used 2021. So the default that popped out would be calculated using well averages from 2021 forward. But they're overridable, so they're not set in stone. If we say IP rate of 18,000 and you're say that's low, then absolutely you can override them.
Awesome. What environments do these models run in?
Right now, it's in terms of coding environments, it's just Python. All of it hits a Python API. So whether you use the front end Excel, it feeds it into a Python API. In terms of the models, how they're coded, a lot of it is the math is a lot simpler than you think, but our internal models for the short-term forecast, I can't dive too deep into the details, but we do have a multiple ways and a multiple suite of model types that we use in terms of that short-term forecast, calculating our modeled IP rates, modeled declines, modeled completion times. I just can't dive into that.
And Python APIs run in a containerized application?
Yeah, so the production studio is hosted on right now Google Cloud, a Google Cloud run. So we have it scaled up pretty big, so there shouldn't be any, like if all of us jumped on right now, you should all still be able to run it. You shouldn't hit high traffic. As we get more clients on board and more people are interested in it, we will scale up to something that can handle this higher level of traffic. But yeah, as of right now, traffic levels have been okay. Let us know if they're not, but it is hosted on Google Cloud.
Awesome. Do you use hyperbolic decline curves? Also, is it possible to show the sensitivity to the TC parameters?
So right now it is exponential entirely. So the front end is a good example because it's more obviously laid out, but on the front end, you'll see three boxes for your decline curves. It'll be IP rate, decline rate, and then a minimum production. And those are basically the A, B, and C value that you would get of a exponential decay. The plan in the future is to add hyperbolic, add other curve types, and then hopefully be able to figure out a way that, say you want to start hyperbolic with a super sharp decline and then move into an exponential with a earlier flat point. That's the plan in the future. But for now, it's exponential.
Awesome. Looks like that is all the questions that we have in here. To all the Hyperion clients on the call, feel free to reach out to me or anyone else at our team if you'd like a further walkthrough or have any further questions on it. And to any non-clients, if you'd like to kind of see it more in action, have another call about it, reach out as well. Okay. Thanks everyone for taking the time.
Thank you.